Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Assistant Professor in the Department of Artificial Intelligence and Data Science, B.V. Raju Institute of Technology, Narsapur campus. I teach the subject is data structures using Python. In that subject, today we will discuss about a small topic, that is how to implement the queues. Now, the implementation of the queues by using the two ways. First one is using arrays. Second one is the using linked list. By using these two ways to implement the queues. Queues using linked list. Queues using linked list. Here, why we are coming from the arrays to linked list means, in that arrays concept, one of the main problem is there. While implementing the arrays using queues, what the problem is? The only is fixed number of data values. Fixed number of data values. Here, initially in that arrays concept, first you can mention the fixed number of the size. The size is 5, 6, 7, 8. Whatever the size, first the size is fixed. After that, we can inserting the element from the every time. That is the drawback. To overcome this drawback, to implement the linked list by using the queues. That means the amount of data must be specified in the beginning itself. That is the drawback. The queues using arrays is not suitable when we don't know the size of the data which is going to use. Here, a queue data structures can be implemented by using the linked list data structures. The queue is implemented by using the linked list for unlimited number of values. We are inserting the unlimited values will be inserting to the linked list. That means the queues using the linked list can work for variable size of the data. Variable size of the data. No need to fix the size of the beginning the implementation. The queue implementation by using the list can be organizing the many data values as we want. Here, in that linked list, the linked list having the nodes. Each node having the two parts. Each node having the two parts. First part is data. The second part is whenever to insert the another element, the size, the address of the next element will be allocating the first element, first node. That is the linked list concept. See this one. The inserting the elements into the rear, delete the element from the front. So this is the 10 value. That is the data value. This is the address of the next value. This is the 15 element. This one is the address of the next one. This address is empty. This address is empty. This one is, we are creating the one temporary node. In the temporary node, we are assigning the address initially. Like this, the address of the next node. So here, there is no chance for inserting the any element in the linked list. The address is null. We are keep it the null value. Okay, that is a simple diagramic representation of the linked list in that queues concept. See algorithms. Here we are performing the NQ algorithm, DQ operation on NQ, DQ and display. We are displaying three algorithms are available here. For NQ operation, we are inserting the element into the queue. What are the different steps to follow the inserting the element? Initially, first we are creating the new node. First we are creating the one node. The new node is a next node to null. Initially the node is null. Now the second step is check whether the queue is empty. How to check? The rear equal to null by using rear equal to null. There is no elements in that linked list. At the time empty method will be applied. Now if the empty, next step it is the empty front equal to new node. This is the friend equal to new node and rear equal to also new node. Friend equal to new node and rear equal to new node. Now when it is empty, it is empty. Otherwise it is not empty. Set rear equal to next. The next is called as new node and the rear is called as new node. That is the NQ of value algorithm. Now we can perform the DQ operation, that means deleting the element from the queue. What are the different steps to follow for deleting the element from the queue? First you can check whether the queue is empty by using friend equal to null. The second step is if it is empty. If the queue is empty, to display the queue is empty. Okay. Now we cannot perform the delete operation in that queues. It is not possible. Terminate from the function. Now the next step is not empty. To define the node pointer is temporary. Initially we are creating the one node. The node is temporary node. That set is friend. Set is friend. Now friend equal to friend is next. The friend is next. Now from the temporary node we are free to temp, means there is no data in that queue. That is the DQ operation. Now we can display the elements. To display the elements means what are the elements available in that queues? All elements will be displayed one by one. Okay. In that process we are follow some steps. First we can check whether the queue is empty. That means friend equal to null. If it is empty, to display the queue is empty. That is to terminate the function. It is not empty, to define the one temporary node. The node having the some address. Okay. 1003, 1004. We have to follow some address. That is the temporary node. The temporary node inside the friend side. This is friend. This is rear. We are creating the temporary node in that friend side. To display the temporary, the node is available. The node is some data value will be. The data value is available here. The data is next to node. To repeat the same until the temporary reach this condition. Temporary next is not equal to null. Up to now to display the temporary value. Finally to display the temporary data is null. Okay. These are the three algorithms where follow the queues using linked list. See, this is the Python program for all the to implementing the linked list. Initially, first we are creating the one linked list. Now we are creating one class. The class having the queue class. That is, first we can initialize the queue. Next one is queue is self dot friend equal to self dot rear equal to none. Whether to check whether the queue is empty. Return self dot friend equal to none. Now we can perform the inserting the elements by using the NQ method. Inserting the elements by using the NQ method. In that NQ, first we are creating the one temporary node for inserting the items into the node. So if self dot rear equal to none, self dot friend equal to self dot rear is having the temporary node to return. Next, the self dot rear dot next is creating the temporary node. The self dot rear is a temporary node. That is the performing the NQ operation. Next, we can perform the DQ operation. Now, self dot empty. First, we can check the whether the queue is empty or whether the linked list queue using linked list. That means the linked list is empty or not. To check whether the linked list is empty or not, is empty method. Otherwise, we are creating the one temporary node in that frame. The self-drive friend is creating the temporary of the next node. If self-drive friend equal to none, self-drive rear equal to none. Okay. Coming to the driver code, first we are creating the queue. After creating the queue, we are inserting the 10 and 20 values by using the enqueue operation. Next, from the queue, we can perform the delete or remove the elements from the queue by using the dequeue. So here the queue is empty. There is no values in that queue. After that, we are inserting the 30, 40, 50. 30, 40, 50. This is another one. This is another one. Okay. Now we can perform the deck operation. This value will be removed. Finally, we can perform the Q friend is 40. Q rear equal to 50 value will be displayed. This is the simple example of implementation of Q using linked list. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.